Okay, so we got the sizing business up and running here. Do you guys want to take a few seconds here? Okay, so let's go ahead and size it. Let me just tell you what the system has. This pump here has a 3 horsepower, and the voltage system is 240 volt, and it's single phase. Can I can I get you guys to can I get everybody to understand? I'm sizing an overcurrent protection device, a conductor, a disconnect, an overload, a controller for a 3 horsepower motor for the swimming pool that we have. Cool? Everybody's okay with what we're trying to achieve? Cool? Okay, so let's go ahead and size a few of these things. Now, before we start, we're going to assume we're using, because it's sump pump, we're going to be using conduit and wire. We're using conduit wire, not an amp cable. We're not using an amp cable. Okay, so the first thing, I'm going to start right in here. The first thing I want to do, guys, is I'm going to start by taking my 3 horsepower at 240 volts. And if you take this one to table 430, table 430.248, thank you, table 248, you want to find a full load current. When it comes, guys, to sizing the conductors, we size everything based on something called full load current for motors. Full load current for motors. So, having said that, I'm going to go fire my NEC code book and take you to this table very quick. Fire my NEC code book, take you to this table. And if you guys grab, here's my table. And I want to make sure everybody knows how to use this table before we even proceed. So let's go to equipment. Come on, am I faster than my computer? Okay. All right, so here's my, okay. Let's go to article. This is where I usually come to it. Here's the table I want you guys to go to. Single phase full load current. Okay. May I have you guys go to this table? This is 430.248. This table, please highlight this one. I'm doing single phase because we're in the single phase business here. Okay. So, what was the everybody's there? Everybody's there at this point? Okay. This is from article. This, which page is that one? Anybody's there? Page.
It says 340 out of 879.
430.248. This one might be slightly different. Okay, so everybody knows how to use this table. The most common mistake is how to use it. We use these tables if your voltage is between 110 to 120, 220 to 240. Any voltage is in between, very important for single phase system. Okay, so what's the voltage of my system? The voltage of my system is 240. So 240 goes usually with the closest, right? For motors, Brian, my friend, for motors, they rate the full load amp based on a lower voltage, because that's the worst scenario. So because my system is 240, I'm going to go to 230, right? This will go with 240 volt system. What's the horsepower? My horsepower is 3. What's the full load current at 3? Can everybody give me a thumbs up? Chad, we know how to use this one. Okay, Aaron, my friend, cool. Everybody knows how to use that one. Okay, so that's it. That's all where I want to go from there. So let's go back into so we got the 3. Everybody knows where we got the 3, right? So let's go back into my presentation and continue with full screen. Okay, so this is 3. What was it again? 17? 17 amps. Okay, so that's step number 1, 17 amps. Okay, so everybody knows where we got the 17 and know how to use this table because it's single phase. Okay, piece of cake. The next one is I'm going to find conductors. So when we find conductors, guys, the conductors, we'll do this one, conductors, motor, branch circuits. Okay, so we're going to go, it's continuous load. So when we find, number 1 is branch circuit. Branch circuit. How do you size branch circuit? You take 1.25, you multiply it by 117, and I need somebody to do a calculator for me fast. and 2 people. 117 times 1.25. 21.25 amps. Cool. Okay, so it's continuous load. Based on the NEC code book, it's going to be continuous load. All right, so continuous load branch circuits. Good to go. Okay, rating and setting of individual motors. Okay, we got that one. All right, so the second thing, what type of conductors are, now you're going to ask yourself, what type of conductors are we using? What type of conductors are we using? Since it's outside, we're using THHW conductors. I'm using THHW conductors in a conduit outside for the swimming pool. Okay, then you're going to take the 21.25, you're going to take this one to table 310.15 B16 under 70 is it 75 degree column. Thank you. 75 under 75 degree column. Okay, so if you guys go there under 75 degree column, let's go size that boy. Everybody's there? 75 degree column. 75 degree column. What's the conductor size I can get under 75 degree column for this boy? I have 21 point, so my next standard is number 12, right? So that would be number, how many conductors on white? It's a 240. How many conductors on white? 2 conductors, number 12 AWG. This is, now remember, number 12 cannot carry more than 20 amps. Motors are exception. You remember how we went through the motors are exception? Motors are exception. Can I have thumbs up, Chad? And why? And what type of insulation am I using? I'm using THHW. I'm using an insulation. So what I'm trying to do, guys, I'm putting a conduit, pulling THHW inside it. 2 conductors. Okay? 2 conductors. Any question about this? Any question about this? The what? We didn't, for motors, remember that when we went through the whole 310.15 B16, we said motors are exception, they're all defaulted, the terminals on them are 75 and we rate them per 75, right? Defaulted to 75.
When we did that text worksheet,
yeah.
For doing the code worksheet, yeah, we had different terminals.
Yeah, this is defaulted to, if you don't know, for motors is 75. Okay, so that's number 1. Any question, guys, about number 1? All right, let's go 2. Number 2. I need over current protection device and its circuit breaker. I need a circuit breaker for over current protection device. Here's what the code says. I need to guys minimize here and go directly to my code and throw this one at you. So let's go to a table, very important table. If you haven't highlighted this table, 430.52. 430.52. 52. Where am I here, Chad? Okay. All right, here you go. So let's go to this table. If you guys have not been there, please go there, highlight it. We're going to be using this table all over the whole year, basically, because that's what we size. We are the engineers, we size it. Okay, everybody's there. Can I have thumbs up that everybody's there on that code? Okay. So this is the table that we use to size over protection device. A few things I want you to know. Dwelling 99%, there are 4 types of overcurrent protection device that protect you from overcurrent. 4 types. 99% of the time, you're going to be either inverse type circuit breaker or dual element time delay fuse, or actually non-time delay fuse. These are, we'll talk about fuses, guys, when we go to commercial industrial. So I'm right now I'm protecting it with an inverse type circuit breaker that looks exactly like the ones that you have right here. That's exactly what inverse type circuit breaker is, right? Inverse type circuit breaker. Okay. Everybody knows single phase is right here, so I'm looking at single phase. If I'm using this type, what's my multiplier? 250. Everybody knows what my multiplier is, 250. And if you read through here, guys, it will tell you if you don't land a standard circuit breaker, you go up. If you read through this table. Can I have thumbs up that everybody knows how to use this table? If I use the fuse, it will be 300. If I use the non-time, delete. If I use a dual element, 175. If I use an instantaneous strip, 800. So we're going to be using an inverse type circuit breaker. Thumbs up. Cool, Chad. Okay, we got that, boy. Let's go back into, so we know where we got that one from. So let's go back, and I'm gonna just put the table here. What was the table again? 430.52. Table 430.52. Okay, so let's go do the math then. 2.5 is 150% multiplied by 17. I need two gentlemen to agree on one answer.
42.5.
Thank you, sir. 42.5. Full screen. I don't want to go full screen. For me here. Full screen. Okay. So how much? I'm sorry. 42.5 amps. Okay. 42.5 amps. You have two options. Go to the bar, drink and cry because they don't make 42.5 amp fuse circuit breakers, right? Or custom design yourself, pay an arm and a leg, and custom design yourself 42.5 circuit breakers. Square D will be more than happy to do that one for you. Or the code allows you to go up. Cool? All right, so then I'm going to take the 42.5, take this one to 240.6, article 240.6, and I would like to flash this one, guys, because article 240.6, let's go flash article 240.6 all the way up to 240.6. If you haven't been there, you missed half of the fun stuff. Okay, 240.6 in particular, I'm going to flash. Where did it go? 240.6, 240.5, 240.6, right here. If you have not, okay, let me move this one here. Why don't you? Are you acting on me? Okay, so let me just erase these quick here and go to 240.6, and just for one time only, from now on when we go to commercial, guys, I'm going to be asking you to go to 240.6 and you say, Chad, we're there. One time I show it to you. So 240.6, these are standard overcompression devices. Here's what we use in the US. Typically, you're going to be, guys, from the 15 amps all the way to 4,000 amps. That's what we typically use. Though it allows you to go to 6,000 amps. For fuses, I want you guys to look at these. Fuses, they make 1, 3, 6, and 10. These are typical standard type fuses. So when I ask you for a standard circuit breaker fuse, what are you going to be referring to? Right in here. Cool. Everybody can have thumbs up, guys. We know where it is. Now, this is only for later on. Only for later on. I want you to come to something called adjustable trip circuit breakers. When we go to the commercial, we're going to be using adjustable circuit breakers. So can I have 550 amp circuit breaker? Yes. What type of 550 will be adjustable? So can I just get your attention? This one will be going when we go commercial industrial. We're going to be using adjustable circuit breakers. Non-adjustable, these are the standard. Thumbs up, everybody. Okay. Now, based on the criteria that I have, what is it, 42? What was the calculation, Jeff? 42 and a half. Okay, 42 and a half. No, go up. Here's a 40, 42 and a half. What was the standard then? 45. It allows you to go up. Do you have to go up? No. Can I go down? Yes. I can go down, but you can't go higher than one step up. Everybody knows why I went to 45? Aaron? Okay. Awesome. So we got that one here. Okay, so we got this. Go back to my multitasking here. Up here, click, and as I move on, Jeff and Darren, I wouldn't go to 240.6 anymore. When we go commercial, when they say go to 240.6, I assume you guys highlight it, you know how to go there, right? Cool. Okay, so we got that one. 240.6. Let me see here. Okay, so let's go. Here you go. By the way, what I'm writing right now is also going to be PDF. This will always be PDF. Okay, so what did we say that 45 amp circuit breaker. Now I want you to look at a number 12 protected by 45. Have you lost your mind, Chad? What happened to the small conductor rules that number 12 cannot be protected more than 20 amps? Exception, motors. Can you have this? You can't believe how many people ask this question all the time. Okay, 45 amp circuit breaker. So my circuit breakers will be 45. Let's keep going. 1, 2, 3. Disconnects. My 3 is going to be disconnect. Can you guys see the disconnect? So 3 is disconnect. For disconnects, guys, I'm not going to go flashy because it's just an article. Go to 430. You're going to go to 430.110 if you don't believe, Chad. And that's how they size it. They take 1.15, multiply it by the 17. Anyone can give me a calculator answer? 1.15. Where did, how much?
20.7.
It's 20.7 amps. Now, where did they get the 1.15? If you don't believe, Chad, please go to 430.110. It tells you you have a disconnect. It's 1.15. Yes, sir.
Correction, 19.55.
That's why I need seconds, guys. How much? 19?
Yeah, 19.55.
0.55. Okay, amps. 19.55. Okay. All right, so that's your disconnect. Obviously, here's your options. Do you guys have DeWalt? Do you have DeWalt yet? This is a must-have next quarter. Yeah, I know. I asked them to order it, guys. Not a big deal. It's going to be coming. Later on, when we go to DeWalt, guys, the standard disconnect that we use in the industry are, they start with 30, 60, 100, multiple of 100. You're going to have them when we have DeWalt. They are in this book. We'll go to them. So what's my standard? You're not going to find them in the code. Here, you're going to go to DeWalt. In this case, page, if I can't find it, of course. Disconnects and all these good stuff. All right, so page 3-12. DeWalt 3-12. The page is 3-12. And the next standard up, you're going to go up. The next standard up is what? 30. So it's the 30 amp. So my disconnect is going to be what? 30 amps. Can I have thumbs up, guys? Yep, we got it, Chad. 30 amps. So that's my disconnect. That's my disconnect. Cool? How do I know it's 30 amps? They don't make 20s. Disconnect. These are the ones that are on the wall right here. That's exactly what the one on the wall. These are 30 amps. Can I use the circuit breaker as a disconnect? Yes. We could have used that circuit breaker if it's within sight as a disconnect. Okay. Any question, guys, about this before I move to the next requirement? You don't need a disconnect.
Or can't you get those panels, just the one breaker on it?
You can. Yep. That will become like a disconnect too. Yeah. Absolutely. Okay, so we're gonna get that one. Now remember, when you guys are sizing, this is you have to size this one for me. We're doing this example for your project. Project is going to be 30. So you're going to come up with a 30 horsepower disconnect right next to the fire to the sump pump, not sump pump, to the swimming pool. Okay, so what's next? 3, 4 is overcome protection device. Can you guys see that symbol here? Is for overcome protection device. Everybody there? These symbol is for contactor overload. So I'm going to go to number 4 is overcome protection device. Okay, here's my overcome protection device. Number 4 is overload protection. Overload protection. For overload protection, guys, I'm going to go flash my code again. Flash my code again. And I want you guys to highlight this one back. The nice thing about electronics, back into my NDC code book. And we're going to go to 430 where do we do the overload, Chad, again? 22, I think, 430 the overload. 430.32. Can you guys go to 430.32? 430.32 all the way. 9, we'll keep moving, Chad. 430.32, 22, 430.32. Did I 35? Did I pass that? Going in a hurry here. To change it for 430.32. Okay, so let's look at this 430.32, and I would like you guys to highlight this one for future references. This is continuous duty motors. Yep. Is it continuous duty motors? Yeah, it's pump. It's a swimming pool pump. Continuous duty. Separate overload protection. That's a typical. And so you guys, 430.32, I would like you to go right in here and highlight the following. 430.32. Please highlight the following. This is where you're typically going to be for overload. So let's look at this. If your motor with a standard service factor of 115 or greater, did we say anything about the service factor for this motor? Do we have any idea what the service factor is? No. So we can't use this one. So 25. Motors with the marked temperature rise of this amount, 25. All other motors that you have no clue what they are, what's your multiplier? 115. So what's your default? 115 unless they tell you information. So where am I going to default? Right here. Can I have a thumbs up, Chad? We know how to default. Unless they tell you otherwise, your default is right there. Okay, so let's go take a snapshot. If I get my snapshot here. Okay. All right, so let's go back. 115, everybody knows why we went to 115. Let's go back. And I hope you guys appreciate what we're doing. I like to go to the code first, and then we can, okay, for load. All right, so here's where we were. Okay, so 115, everybody knows that was from 430.32. All right, so 115, 1.15 times. This is the only place in the NEC code book that you don't use the full load current, the 17. You use the nameplate. So I have to give you the nameplate now, okay? The only place where you have to use the nameplate. So I have to give you full load amp nameplate. Not the full load current, the full load amp nameplate. Okay, so given, this have to be given. You can't find it from a table. So do you guys remember what was the full load current that we got? 17, right? Typically, the full load amps on the nameplate is slightly lower than what you get from the table, okay? So I'm going to go there and I'm going to take 1.15 multiplied by 15 amps. Where did they get the 15? Given by manual. Given by manufacturers. I'm giving you that this motor is 15. The full load amps is 15 for it. Can I guys get you to nameplate full load amps is 15? Given. That's the one that you use. You don't use the one from the table, the 17. Okay, what's the math on that, please? 17.2 amps. So that's it. You don't do anything. You come to the overload. Here's my overload here. You come to your overloads. Should be an overload here. And you tweak your overload slightly. Looks like this. You tweak the overload slightly to get your 17.2. You can't get 17.2. What do you get? 17. You don't go up. What does the overload do, guys? It protects the motor from being overloaded. So if you are supposed to pump, as I always say, a water pump water to 2-story, and you install it to pump it to 6 stories. So now you're overloading your pump. Cool? 17. The last thing is number 5. Number 5 is controller. Everybody knows what the function of each one of these for the motors. What does the controller do? Turn on and off the equipment. That's what the function of the controller. Turn on and off of the equipment. Now this controller, disclaimer, it could be most of the time, guys, provided by the manufacturer. But if we are to provide an NEMA contactor like this, here's what you're going to be doing. For motor controllers, you're going to go to 430 The article for it is 430.83. You're going to hear Chad talking about this one. If you guys go there, there's nothing to see other than read the article. If you read it, here's what it tells you. You have to size it based on the horsepower and the voltage. What's the horsepower? 3 horsepower. 3 horsepower. What's the voltage? At 240. And what's the phase? Single phase. So you have to go size it based on 3 horsepower, 240 single phase. 240 single phase. I'm going to stop at this point. Later on, guys, when you have DeWalt, we go and find the actual NEMA for 3-phase motors. We can find the actual NEMA size for the contactors that we can use. The actual NEMA size. Any question, guys, about this? Sizing these stuff for motors. Sizing it for a motor. Any question? So we size it for motors. I have one other example about the water heater. I'm going to size for the water heater, and then I'm going to stop. I promise you. Before I leave the motors, though, everybody now, this is not the first time I'm going to hear it with me, guys. We're going to go to chillers later on, next quarter. We're going to do a chiller example, 3-phase. I picked the single phase because we're in the single phase business here. So this is for your the horsepower for your pump, for swimming pool pump. Everybody knows how to size it. On the test, there will be an example like this, just FYI. Yeah. Yes, we're doing single phase now because it's residential. We will do 3-phase as we move on. Okay. So any questions? So what we did, we installed a 45 amp circuit breaker. We pulled a conductors, 2 conductors number 12 out of that, and we brought a disconnect. My disconnect was 30, and a controller. We didn't size the controller. It's just a NEMA. Later on, we'll size it. Overload protection was, what was it? Whatever the size is, and and then all the conductors in between. Before I leave this, do you remember, guys, when we came here, we said 2 conductors number 12. Now what happened to the ground? The grounding conductor. I want to do this exam. I'm going to size. Do you have to have a grounding conductor with it because they're inside a conduit? Yes. So let's go size the grounding conductor that goes with it, because this is very important. I'm going to say just a note here. The last thing, equipment grounding conductor. Size the equipment grounding conductor. Here's how they do it, guys. Take the 45 amp, take it to table 250.122, and size, we're all covered. So let me go to 250.122 here. Very quick. 250 to size the equipment grounding conductor. 250.122. Where am I here, Chad? 250.122. 250 right here. 250.122. I start from the end. Usually it's easier because it's 250. Are you guys there? You probably, here you go. That table. Okay. How many of you guys have seen this table before? You've seen it? Okay. So this table is how we size the equipment grounding conductor. Everybody knows what the equipment grounding conductor is, the ground. And why do I care? Because I'm not pulling a cable. I'm pulling a separate conductor with it. Take this. We size it based on the overcurrent protection device ahead of the circuit. What was the overcurrent protection device, Darren? 45. So let's go to 45. Where's 45? I have 15, 20, 60. So where am I going to go then? To 60. And what's the conductor size? Number 10. Now, before you write number 10 though, before you write number 10, what was the phase conductors? So I have, here's a conductor. I'm going to write the circuit here. And here's my machine, my motor, my 3 horsepower pump, okay? These conductors, guys, these 2 conductors were what? 2 conductors number 12, AWGTHHW. Cool. And I need to pull an equipment grounding conductor here. Here's my ground from the panel, and I will pull an equipment grounding conductor. Based on this table, what's the size? Number 10. What's the ungrounded conductor? Number 12. In the motor, right in the motor, it says the equipment grounding conductor is not required to be larger than the ungrounded conductor. One more time. This is typically for motors. The equipment grounding conductor does not need to be larger than the ungrounded conductor. So yes, we came with 10, but we default to what? To number 12 minimum, as a minimum. Why? Because the ungrounded conductors are number 12. Can I have a thumbs up that we fully understand that? So and that happens only with motors, because the overcome protection devices are way oversized, you end up with a bigger conductor, grounding conductor than the phases. Doesn't make sense, right? So the code in Article 430 allow you to go down to the size of the conductor. Okay, so everybody knows why the conductor is going to be number 12 now? Okay, so now instead of number 10, now everybody knows how to use this table too. Everybody knows how to use this table. This is how you pick the ground based on overcome protection device. So for example, if my ground, this is just another example. If my panel is 400 amp panel, sub panel, I need to pull a ground. What's the ground with it? Equipment ground conductor, number 3. Okay, everybody got that one? Cool. So that's basically what my conductors are. Let's go back to my conductors and full screen. And then the conductor would be number 1 conductor, number 12AWGTHHW done. Not number 10. If you put in a conduit, insulated. It can be, but you can't put anything. Yeah, you don't want to put anything bare. You're putting them in a conduit. Yes, sir.
I think in the pools for grounding.
And for the pools, thank you. We're close to. Yeah, if we're around the pool now. I forgot that this is a pool. Has to be insulated too. Okay, one more very quick example, just for the water heater, and then we're done. All right, so let's go back into one example here. This is how I do my calculation. Just I know I haven't done, as we move on through the year, I do the calculation like this, guys. First it's recorded, second is PDF, and then put it in the network. Everything that I write here is PDF. Okay, cool. All right, here's an example. Example number 2. Now here's one example. I have an overcome protection device, and I have a water. This is a water heater, and my water heater is 5,000 watt. 5,000 watt water heater. The voltage system is 240 volt. And I need to size the following for this boy. I need to size number 1, conductor. Number 2, overcome protection device. Conductor and overcome protection device. Conductor and overcome protection device. Okay? And let's say it wasn't within sight, and I'm going to grab here and size a disconnect. That will be number 3. Number 3 is my disconnect. My disconnect, right? So if it's not within sight of the overcome protection device, I need to size a disconnect. That's it. What happened to the controller and the overload chat? That's all built into the water heater. Cool? Built into the water heater. Let's go do that. By the way, before I move on, Aaron, everybody knows, as you move with Chad, I use what this is called one-line diagram. Every time we have an example, we start with the overcome protection device in the panel. We pull a cable, we put a disconnect. Next to the disconnect, we put the machine. Everybody knows what I'm drawing here, and I'm only showing one line. It's called one line. So actually, since this is 240, how many circuit breakers are you going to have? 2 pole circuit breakers. Since this is 240, how many conductors are you going to have? 2 conductors with a ground, right? Everybody understand that without writing it? As we move forward, that's called one-line diagram. That's, as designers, you guys are going to be doing that all the time. A riser, a one-line diagram, and size. Okay, let's go size it. So the first thing you need to do is find the full load current. I equal, what is the 500 kW? 500 W divided by what's the voltage? 240. I need 2 gentlemen to agree on one answer.
20.83.
Thank you. 20 4.8 amps. We size things based on amps. Find the full load current of this water heater first. The full load current of this water heater. We need to find the full load current of this water heater. Now, water heater is not a pump. It's not a motor. So we don't apply the rules of a motor on it. It's an appliances. With appliances, guys, they're continuous load. So we size them based 125%. So, okay, so we are in Article 422. That's the article that applies for appliances. Okay, so the first thing I'm going to size there, one, branch circuits. This is called branch circuit. Branch circuit, basically conductors. 1.25 times 20.8. Where did I get the 1.25? I got it from 420 dot 10. 420.10. 420.10. If you guys go to 420.10, it will tell you it's a continuous load and multiply it by 1.25 in any sequence. Nothing really other than just says it's continuous load multiplied by 1.1. Okay? Branch circuit rating, continuous load. Okay, so with this, anybody can give me what the answer is, please? 26 even?
26.0.
Okay, 26 even is good enough. So I got 26 amps. Cool? 26 amps. Now, the next step is what you do. You take 26 amp, take this one to table 310.15 B16. 310.15 B16, guys, under which column and why? Is this a motor? No. So what's your default? 100 or less? 60. More than 100? 75. So go to 100 less. What's under 60-degree column? So we're going to go 60-degree column. What's the size? Number 10? Can I have a second? Number 10. So how many conductors though? Two conductors, number 10AWG. Now this could be an NM cable because it's 60-degree column, or it could be a THHN because it's also THHN can be sized under a 60-degree column, right? And most likely if it's residential, it's going to be an NM cable, 60-degree column. Okay, now we size it. We'll come to the ground in a second. Okay, number two. Number two is overcurrent protection device. Overcurrent protection device. I want you guys to go to 220 dot, for this particular one, we're going to go to 220 dot, 220.11. 220.11. If you guys go to 220.11, as a matter of fact, let's just flash that one. 220.11. It's really nice. 220.11. Let's go to 220 here. Here's the 220, guys. 220 dot right 220. I'm sorry, not did I say 220? It's 420, Chad. Did I write 420 or 220? 420. Why do I lie to you all the time? Okay, let's go to 420. 422. Dot. What did they say? 422.11. Okay, motors dot 11. Did I pass it right? 422.11. It's one more. There you go. 422.11 single phase motors right in here. I'm gonna go erase these so I can't see my stuff. This is where I would like you guys to go. There gotta be a way of getting rid of this. I can't figure it out. This no. Okay. I would like you guys to look at this, please, and keep it for future use. Appliances. Here's what I would like you to highlight. This section here. Now, what is the definition of appliance? They define the appliance, guys, any equipment that commercially available, manufactured for use. For example, water heater is an appliance, dishwasher is an appliance. So commercially available. Industrial machines are not appliances, okay? So for appliances, not to exceed the marked on the appliances. First of all, is it marked on appliances? Don't exceed it. If it's not, if the full load amp is 13 or less, don't put smaller than 20 amps. That's when you guys sized garbage disposal. What did we say? 20 amps. When we sized also garbage disposal and dishwasher. When we sized the dishwasher, what did we say? 20 amps. Because the full load amps is less than 13 or less, 20 amps, no question asked. Can I have thumbs up, Chad? We got that one? Cool. Now, if it's more than 13, then they allow you to use this multiplier, 150. If the full load amp is more than 13, 150. Thumbs up. So does this apply to us? More than 13 amps? So that's where we're going to get the more than 13. So let's go take a snapshot of that boy. Okay, and go back. Then you guys understand where we got the full, and we got these. I'm going to go back. Okay, so now everybody knows where I'm going to take 115, right? So let's go to 115, 1.15 times, what's the full load amp here? 20.8. I need two gentlemen to agree on an answer.
1.5 or 1.15?
1.5, 150%.
31.2.
31.2 amps. Okay. Now, let me just see. I think it tells you guys here. You guys write. It says where the 150 does not correspond to a standard overcome detection device. Look at what they ask you to do. Use the next standard. If it doesn't correspond to that particular standard, so what do? Use next standard. You can use next standard. Cool. All right. So here's my option. That's directly from there. So I have 100. Where am I here? So I have 131.1. So I have two options here to make. Let me just cross this one. Okay, now hold your horses. I have two options to make. So technically, I could take this one to 240.6, and that will give me 35 amp. Okay? But there's one little problem. What happens if I put a 35 amp on a number 10? Is it allowed by code? It's not a motor. Is it allowed by code? No. So you have two options to choose from. Either you make this 35, but what do you need to do to your conductor? Go to number 8, or instead of going to 31, can I go down? Yes, there's nothing wrong with going down, right? So I go down to 30. So two options. The code allows me to go up, but I can also go down to 30 amps. And if I go to 30 amps, would the 30 amps allow to protect number 10? Yes. Am I good to go? Yes. I can't emphasize. Two options there, and you have to do. Option number 1, either you go by the code and go to 35, then go back and change this conductor to what? Number 8, because number 10 is a small conductor. You can't protect it for more than 30. The option that I would use is I would go down to 30 amps, because you can always go down. You can't go up on circuit breaker. You can always go down. I use 30 amps, and I keep my conductors number 10, and that's what we did, what you guys sized, right? Number 10, that's what we came up with, number 10, 30 amps. Can you have thumbs up, Chad? We understand fully that we can go up and we went down because we don't want to pull a conductor larger. That's why we become designers, guys, and we start thinking about things, not just implementing them. Okay, so that's basically what, so you have a 30 amp. You have your 30 amp water heaters. So what's the last thing left? Disconnect. Now, if you have, now remember, you disconnect, if the overcome detection device within 50 feet of the appliance is done, you don't need a disconnect. If it's not a disconnect, if you don't have it, here's how the code doesn't say exactly how to size it, but I size exactly 1.25, like continuous load for my disconnect. So let's go back to the disconnect. and back again, and back again, the front. Am I going back or forward here? I think I'm clicking on the wrong one here. Okay, here you go. My finger is too fat. Okay, here you go. We were here, right? The last thing I'm gonna size is, guys, is number 3, the disconnect. So let's go here, disconnect, number 3, and then we're done. Number 3, disconnect. Disconnect, that's my good CSK. Disclaimer, that's for my initials. So if somebody say that I'm gonna rock, they say that Chad. So I would use 1.25 multiplied by, what was the full load current again? 20. Thank you. 20.8, and that would give me, we did the math on that one. What was the math? For the conductor, we didn't. What is it?
26 amps.
26 amps. Okay? Then I do 26 amps taken to D wall 3-12, and that would go up to 30 amp. So I have a 30 amp disconnect. 30 amp disconnect. So that exactly like the one on the wall. Throw a 30 amp disconnect right next to it. 2-pole. 30 amp 2-pole. Any question, guys? Any question about that? So we did 2 examples. One about a motor, which is basically a pump, and the other one about appliances. Any questions? Now, if I give you guys another example, would you be able to do it? Any examples based on these rules, appliances and sump pump? Now, this is not your first time touching motors, as I said. The way I do it, Darren, is we have machines as we move through. We grab these machines, we size them. Because that's what you're going to be doing, sizing for machines and air handling unit and so forth. Okay, that's all I have. Thank you. Like I said, guys, this will be PDF'd and put in the network.
So what